In typical fashion, we're looking at more and more complex, more complicated problems, but in each one, the process is the same. We just need to break it up into parts. With this problem, we're asked to perform the indicated operations. We have a rational expression times another rational expression divided by another rational expression. So our first step is we need to write the division as a multiplication. So we flip it and multiplies. We take the reciprocal and we multiply. So we write down 4m plus 4. And let's go ahead and let's since the next step is factoring anyways, let's go ahead and factor these first two rational expressions. 4m plus 4, well, that has a common factor of 4 in both terms. So 4 times m plus 1. 3m minus 15, well, that has a common factor of 3. 3 times m minus 5 times m squared minus 3m minus 10. So what two values, since the leading coefficient is 1, what two values multiply to negative 10 and add to negative 3? Well, 5 times 2 is 10, and if we make the 5 the subtraction, that will give us a negative 3m. m squared plus 2m minus 5m is minus 3m, and then minus 10. And then m squared minus 4 minus 32, what two numbers multiply? Again, the leading coefficient is 1, so we just look at what two numbers multiply to 32, negative 32, and add to negative 4. Well, how about negative 8 and 4? So m minus 8 times m plus 4. And if we multiply back through, that does give us m squared plus 4m minus 8m is minus 4m, and then negative 8 times 4 is negative 32. And then we will flip and change this to multiplication. So we have times 6m minus 48 over 12m minus 36. And I'm going to go ahead and factor those as I put them down, because we're just making the numerator the denominator and vice versa. So let's look at 6m minus 48. That's a common factor of 6. So 6 times m minus 8. And then 12m minus 36, we're taking it from the top to the bottom, from the numerator to the denominator. That has a common factor of 12. 12 times m minus 3. So now we multiply across the top, multiply across the bottom. So 4 times m plus 1 times m minus 5 times m plus 2 times 6 times m minus 8 over 3 times m minus 5 times m minus 8 times m plus 4 times 12 times m minus 3. And technically, we should put the 12 and the 6 in parentheses as well. And now we just cancel common factors in the numerator and denominator. So there's several ways we could do that. We could take, and let's just start at the front and move our way over. If we have 4 divided by 4 is 1, 12 divided by 4 is 3, 6 divided by 3 is 2, and 3 divided by 3, doesn't matter which one we take care of, 3 divided by 3 is 1. M plus 1 is only in the numerator. M minus 5 and m minus 5 cancel. M plus 2 is only in the numerator. M minus 8 and m minus 8 cancel. And we're left with, let's bring the coefficients out front, or bring the constants out front, so 2 times m plus 1 times m plus 2 over 3 times m plus 4 times m minus 3. And remember that technically, even though we're not being asked to, technically we should also note that m can't equal, and I'm just going to write out all of the numbers in commas, m can't equal 5, 8, negative 4, or 3. And again, that comes from all the factors that we had in the denominator. If m equaled any of these values, we'd end up with a denominator of 0. Technically as well, we should check the original denominator of 6m minus 84, since we were taking it to the numerator and then multiplying. But that still all comes out in the wash, because that ends up equaling, when we factored out the 6, m minus 8. 6 times m minus 8, and we already have m can't equal 8 because of the common factor that was in the denominator. So again, anytime we have multiple operations, if there's division, take the reciprocal and turn it into multiplication, and then the process is exactly the same as it was before, just with more rational expressions. We factor every numerator and denominator, then combine numerators and denominators, cancel common factors in the numerator and denominator, and then what's left is our solution to all of the operations.